was in charge of coordinating the observing to characterize the object.
Our planet is indeed diminutive, evident when observing the immense stretch of space. Within this cosmic arena, peculiar entities, or potential visitors, traverse. Presently, an outsider from a distant realm, Oumuamua, reappears, enveloped in its enigmatic presence, captivating onlookers as it traverses through space. What is Oumuamua? What drives its existence, and what prompts its appearance? Continue watching to uncover the answers. No celestial object has intrigued scientists as Oumuamua has over the years. Remarkably, this peculiar object is acknowledged by scientists as the initial interstellar visitor to our solar system. Discovered on October 19, 2017, by Robert Warwick, using the Pan-STARRS telescope at Haleakala Observatory, Hawaii, Oumuamua has engaged scientists since its detection. It takes on a cigar-shaped form, measuring approximately 100 to 1,000 meters in length and 35 to 167 meters in width. Beyond its unusual shape, every aspect of the object appears peculiar, from its red color to its distinctive behavior, akin to objects within the solar system. Let's delve into some of the unique characteristics of this object, shall we? Firstly, despite its close proximity to the Sun, Oumuamua displayed no indications of having a coma or visible dust. Additionally, it demonstrated non-gravitational acceleration, possibly stemming from outgassing or solar radiation pressure. While its rotation rate aligns with that of asteroids in our solar system, limited models support its elongated nature compared to most other natural bodies. In straightforward terms, Oumuamua's origin remains uncertain. It might have been expelled from a planet or star system in another galaxy, or it could have originated in the early solar system and later ejected through gravitational interaction with a planet. This discovery marks a significant event in astronomy's history. It's the initial instance of observing an object from a star system beyond our own, offering a unique chance to explore the universe. Notably, it's the first object observed traveling at a speed surpassing the Sun's escape velocity, exhibiting non-gravitational acceleration, featuring a cigar-shaped form, and likely originating from outside our solar system. Oumuamua's path indicates its origin in the Lyra constellation, approximately 600 light-years away. Zooming through the solar system on September 9, 2017, at about 196,000 miles per hour, it's now heading back out. The origin and nature of Oumuamua pose a mystery, sparking various speculations about the object, some of which can be amusing. Some scientists propose it's a comet, possibly shaped by its atmosphere, while others suggest it's an asteroid elongated by tidal forces. Another viewpoint considers it as an artifact object, like a probe from an alien civilization. There's also the possibility that it formed in a binary star system, where one star outweighed the other significantly. If a more massive star perished, it could have expelled the outer layers of the less massive star, releasing comets and asteroids into space. Oumuamua might be one of these objects or none at all. To maintain a rational perspective, Oumuamua is hypothesized to be a cometary or asteroid body expelled from a different star system. It's also believed to be quite ancient, estimated to be at least 100 million and possibly billions of years old. With a very low albedo, reflecting minimal light, it indicates extensive travel through space, potentially exposed to substantial cosmic radiation over an extended period. So, what makes Oumuamua so peculiar? Its peculiarity stems from its divergence from our established knowledge of celestial objects. What mystery surrounds Oumuamua? Let's assess the probabilities, shall we? Initially, some scientists propose that Oumuamua might be a comet, yet it appears to have shed its coma, a departure from the typical behavior of comets in our solar system. Another hypothesis suggests it could be an asteroid, but this is an even less favorable choice as asteroids typically adhere to gravitational forces, unlike Oumuamua. Certain scientists have floated the idea that Oumuamua could be an alien spacecraft. While Loeb supports this notion, not many scientists align with him due to the lack of evidence supporting this theory. This leaves Oumuamua with alternative possibilities lacking substantial evidence. For instance, it might be a fragment from a planet destroyed by a collision or a piece of a comet torn apart by the sun's gravity. Another option is that it's a natural satellite ejected from its parent planet, or perhaps even a man-made object like a space probe. There's also the chance that Oumuamua is something entirely unprecedented. The possibilities are diverse. Adding to the intrigue, Oumuamua exhibits an unusual acceleration rate, and various explanations are plausible. One potential cause is the release of gas and dust from its surface through outgassing. As the object heats up, this emission creates pressure, propelling the object forward. Another potential explanation is that Oumuamua is a comet that has shed its coma. The coma, a cloud of gas and dust encircling comets, typically forms when a comet approaches the sun. The sun's heat causes the ice in the coma to vaporize, producing a trail of gas and dust. However, Oumuamua displayed no indications of a coma during observation. Its outgassing system appears to have left its surface clear, revealing no dust but a layer resembling ice beneath. Continuing its acceleration, some scientists consider the idea that Oumuamua is driven by solar radiation pressure. Although solar radiation pressure is a feeble force, it can be impactful for objects that are either very large or exceptionally thin. Given Oumuamua's highly elongated shape, solar radiation pressure might contribute to its acceleration. There's also the possibility that Oumuamua's acceleration stems from an unidentified force, perhaps unrelated to alien influence, as suggested by Loeb. In 2023, two groups of astronomers collaborated, suggesting that Oumuamua's acceleration might be attributed to the release of hydrogen gas from its surface. Despite expectations based on gravitational interactions with the Sun and planets, Oumuamua accelerated away from the Sun while traversing our solar system. This acceleration couldn't be accounted for by known cometary or asteroid behavior, sparking speculation about Oumuamua potentially being an alien spacecraft. Jennifer Bergner and Daryl Seligman from the University of Arizona put forth the hydrogen gas theory. They propose that Oumuamua is made of hydrogen ice formed in interstellar space. As it approached the sun's heat caused the hydrogen ice to sublimate, transitioning directly from solid to gas. The released hydrogen gas would have escaped from the object's surface, generating a slight thrust that propelled Oumuamua away from the sun. The hydrogen gas concept is supported by various observations. For instance, Oumuamua displayed a highly elongated shape, a characteristic that could be explained if it were a sheet of hydrogen ice stretched by the sun's gravity. Furthermore, Oumuamua exhibited no signs of cometary activity, such as a dust or gas tail. This aligns with the notion that Oumuamua is not a comet, but an entity comprised of hydrogen ice. However, this theory has its challenges. It remains unclear how the hydrogen gas would have escaped from the object's surface without being impeded by its gravity. Despite the hurdles, the hydrogen gas theory presents a plausible explanation for Oumuamua's acceleration. It's a straightforward and practical proposal that aligns with all available observations. If the hydrogen gas theory holds true, it suggests that Oumuamua is the initial interstellar object influenced by a non-gravitational force. Although Oumuamua vanished from our view within the solar system back in 2017, it has made a final appearance, now departing our solar system and anticipated to vanish completely within the year. Regrettably, this occurs at a critical juncture when the Vera C. Rubin Observatory is still under construction. Formerly known as the Large Synoptic Survey Telescope, the Vera C. Rubin Observatory is a currently developing astronomical observatory located in Chile. Set to finish construction in 2025, this observatory aims to scrutinize the universe by capturing sky images every few nights over a decade. This extended observation period will enable astronomers to delve into the evolution of galaxies, the genesis of stars and planets, and the quest for dark matter and energy. Had the observatory been operational before the appearance of Oumuamua, it could have detected the object much earlier. As Oumuamua follows its current trajectory, it is anticipated to exit the solar system and journey back into interstellar space. The possibility exists for its return to our solar system or encounter with another star system in the future. With Oumuamua seemingly departing our solar system, scientists can only speculate if its arrival was a unique, once-in-a-lifetime event, as there's no certainty of its return. Despite being unable to influence Oumuamua's path, scientists remain persistent, expressing a willingness to explore the peculiar object if feasible. Fortunately, achieving this is feasible, and scientists are already putting forth practical suggestions. One such proposal involves employing solar orbit maneuvers. The solar orbit method suggests utilizing the sun's gravity to propel a spacecraft around it, granting sufficient speed to intercept Oumuamua. While less complex and costly than the gravity assist proposal, it necessitates a more precise calculation of the spacecraft's trajectory. In the solar orbit approach, a spacecraft would be launched, utilizing the sun's gravity to slingshot around it and gain the necessary speed to catch up to Oumuamua. Subsequently, the spacecraft would utilize a solar or laser sail to accelerate up to 1 million miles per hour, a velocity adequate to reach Oumuamua. The solar orbit method shows promise in the pursuit of Oumuamua. However, it's still in the early stages of development, and its feasibility is yet to be determined. Apart from the solar orbit maneuver, an alternative suggestion involves utilizing a gravity assist from Jupiter to propel a spacecraft around the planet, granting it sufficient speed to catch up to Oumuamua. Another proposal suggests employing a solar sail, a sizable thin sheet moved by sunlight pressure. A solar sail could propel a spacecraft to speeds of up to 200,000 miles per hour, enabling it to catch up to Oumuamua. Nevertheless, these ideas pose significant challenges and come with high costs. The gravity assist approach necessitates precise trajectory calculations, while a solar sail requires a substantial and potent design. It remains uncertain whether either of these proposals will be viable in the near future. There's a suggestion to utilize a laser sail, a variant of a solar sail driven by a laser beam. Laser sails are in early development, but hold the potential to surpass traditional solar sails in power. If a sufficiently potent laser sail could be created to propel a spacecraft at speeds reaching 1 million miles per hour, it becomes feasible to intercept Oumuamua. Now, let's delve into the Lyra project. The Lyra project, initiated on October 30th, 2017, by the Initiative for Interstellar Studies, explores the feasibility of a mission to interstellar objects like Oumuamua and 21 Borisov. Dr. Bruce Betts, a senior scientist at I4IS, leads the project. Lyra assesses various methods to catch up to Oumuamua, including the solar orbit approach, gravity assist, and solar sail or laser sail. Additionally, the project explores the development of new technologies such as laser sails to enable the pursuit of Oumuamua. Project Lyra seeks to evaluate the practicality of dispatching a spacecraft to Oumuamua, or 21 Borisov, within a time frame of 5 to 25 years. The key challenge lies in reaching the asteroid within a reasonable time frame and distance from Earth, while obtaining valuable scientific data. Potential approaches include utilizing a gravity assist from Jupiter to enhance the spacecraft's speed, employing a laser sail for propulsion, or utilizing a nuclear thermal rocket. The optimal choice depends on factors such as the spacecraft's mass, distance to the asteroid, and scientific objectives. Although Project Lyra is in its early phases, it holds the potential to be a groundbreaking mission, shedding light on the universe's life origins. The project's estimated cost is in the several billion dollars range, and completion is anticipated to take multiple years. While Project Lyra is an ambitious undertaking, the potential benefits are substantial, and the project team is committed to transforming it into a reality. The recent observations of Oumuamua have provided valuable insights for scientists. The in-depth examination of this celestial visitor has revealed that Oumuamua is not the sole interstellar object to have journeyed to Earth. Based on distinctive features marking it as an interstellar object, scientists now confidently assert that the previously encountered 96P Mach-Holtz, which traversed our solar system earlier and executed dramatic orbits around the Sun, is also an interstellar comet. This revelation underscores that Oumuamua isn't the initial interstellar object to visit Earth, and there are likely more to come. Even if scientists don't manage to intercept Oumuamua, it is anticipated that similar enigmatic objects will make appearances in the future. This growing awareness of interstellar visitors opens a new chapter in our understanding of celestial dynamics. The study of Oumuamua, coupled with the recognition of 96P Mach-Holtz as an interstellar comet, suggests a broader population of such objects traversing our cosmic neighborhood. The unique traits observed in these interstellar visitors challenge conventional expectations, prompting scientists to refine their models of celestial object behavior and origins. The prospect that Oumuamua is not a solitary anomaly, but part of a recurring phenomenon, sparks anticipation among researchers. While the elusive Oumuamua may elude direct study, the experience gained from its observation and the subsequent identification of 96P Mach-Holtz as another interstellar visitor enhances our ability to detect and characterize similar objects in the future. This expanding field of interstellar object research holds promise for unraveling mysteries about the diverse origins and journeys of celestial bodies. As technology advances and observational techniques improve, scientists remain vigilant, poised to explore and decipher the secrets carried by these interstellar travelers, ensuring that each encounter contributes to our evolving understanding of the vast cosmos that extends beyond our solar boundaries. What do you think about the speculations around Oumuamua? Do well to share your thoughts in the comments section below. And if you found this video helpful, feel free to like it, share it, and subscribe for more of its kind.